Hello guys, welcome back. So in this video we are going to understand the hard question, that is Q3, and as you can see here we have given two positive integer n and k, and an integer x is called palindrome, right? You can say if x is a palindrome and x is a divisible by k. So an integer we have given is called good if the digit can be rearranged to form the k palindromic integer. For example, if we have given k equal to 2, like we will make 2020 can be rearranged to form the k palindromic integer into 2002, you can say, right? Where 101 cannot be rearranged to form the k palindromic integers. Okay, so we have to return the count of good integers, and that contains n digits, you can say. So we have to do right we have to return the count of good integers that contains n digits. Okay, we have to note that any integer must not have leading zeros, neither you can say before nor neither before nor after rearranging. For example, 101 cannot be rearranged to 101 like that. Okay, so as you can see we have given n equal to 3, k equal to 5. So in explanation you can see we have given some of the good integers we have given, like 551, right? And because it can be rearranged to form 515, and if you'll do 5 to 5, right? So it will help you to make arrangement, right? As you can see 515 we can do that, but what about the 5 to 5, right? It's already palindrome, right? So we have to see that, right? Like that you have to form and you have to make. So other examples are there, you can pause and you can see here, right? So for these steps, right, what we can do, first of all, to solve this, what approach you will follow, right? So to solve this you can make the approach like, first we will generate all the possible integers with n digits, and then we will generate all the possible integers with n digits using the permutations, right? Then what we will do, we'll check for the palindromic conditions as we have seen in the example you can see here, and for each number generated we will check if it is rearranged to form the palindromic or not, right? So if it is palindrome, then what we will do, we'll make the divisible by given k, and we will check for all the leading zeros also, right, to ensure that no number has been the leading zero after the rearrangement, right? Then what we will do, we'll count the valid palindromic integers, and we'll count how many of these numbers meet to the conditions, right? So you pause this video and you can follow this approach, because this is hard problem, because still I'm getting, you can say, time limit exceed, right? So I have to figure out what is the cause here, because test cases are getting passed, but some test cases not getting passed. So I have to pause this video and I have to make it right complete, and for that, like, I can help you. What you can do, you can see the code, what the approach is there, and you can try by yourself, right? So what you can do here, first of all, you have to create the methods, right? Let's suppose we have we can create a private method called palindrome that will check the palindrome, right? Then what we can do, we can make the can rearrange to the palindrome, and we will do divisible, right? So we will generate all the permutations first, and then we will check the divisibility by the k, and we'll check if it is there, then we will return true, otherwise we'll keep checking that. Okay, next what we will do, we will find the next permutations, right? So Google has already asked this question, next permutation, as you know, right? So in the next permutation, what we have to we used to do, we will check for the next permutation, right? If you not aware with Google it, right, next permutation, or either I'll upload today or tomorrow I'll upload a video, you can see the next permutation video. Okay, so in the next permutation, what we used to see, first we'll go with all the positive integers, right, a of I to the next a of I, like current value we can say, right? We will check, right? And why we are going with the I minus 2, because last two digit we have to check, not the first one. Because if, let's suppose we have given how we are talking about, let's suppose we have 1 3 2, right? So these three number, let's suppose we have, right? So what will be the permutation of this number, let's suppose, right? So we know that after 1 2 3, let's suppose it is 2 here, it is 2 here, here is 3, right? So what should be the next permutation? So next permutation we can say it will become 1, we will not change the 1, but what will happen, 3 and then 2. So this will be your next permutation, right? So like that we have to check, right? So for that you have to check if the array of I is greater than equal to array of I plus 1, means this one, then we'll reduce I minus minus, or we'll return I should be less than 0, then we return false. Otherwise what we will check, we will check for the if array of j is less than array of I, then in this case we will return minus minus. So we can do swap and then reverse. So last two digit we will, as you have 1 3 2 was there, 1 2 3 was there, we are reversing that integers, right? So you have to pass the integer and its index, you can say, and then we have to reverse, and finally we will return true. If it is the next permutation of the array, you will return that element. You have to reverse, you have to swap, and then you have to reverse. You have to swap the index of the array, and then you have to reverse. So for that you have to make a swap, right? And another is reverse. If you're taking my class, you can understand this easily, right? Let's suppose if you are going with the good, then yeah, you have already done the swap and reverse, then you will use all these here in the to finding the good integers, right? How we'll take a count and we will return this count finally here, right? This question has been asked in the Google, okay? And for that you will get the start index, end index, like this, n minus 1 we will take, and then we'll start with the start, it will go to the end, and what we will do, we'll check can a rearrange to palindrome and divisible, means it will check internally all the next permutation. If it is coming true, then it will do count plus plus and it will return, right? So either I'm thinking what we can do here, because time limit is exceeding, right? So I have to store all these next permutations somewhere, and then I will keep checking here. So while I'm checking these things, right, while next permutation is there, I'm doing the checking again, right? So I want to hold somewhere, and so that the time exceed limit will go away. So let me figure out, or either I will upload in tomorrow morning. Thank you guys, thank you for watching this video, and I hope you understand this video, and it will help you to complete this program. Thank you for watching this video.